Hello everyone, my name is Mr. Pogachnik and I'm going to be taking you through the guided notes for 5.1, the universe. The universe is a pretty big place, very big, huge, so big we can't see across it. And what we're going to examine is a bunch of different phenomena, different things that exist within this universe. So what is the universe? Well, the universe is all the existing space and matter as a whole, also known as the cosmos. In this picture, you can see stars, galaxies, and other different formations that exist in a small little area of space. So where did it come from? Well, this is a really good question. What we think happened is what's called the Big Bang Theory. The Big Bang Theory states that the universe came from a singularity that started expanding almost 14 billion years ago. The singularity, way over on the left-hand side of the picture, was a super small, super dense energy source that then expanded. Big Bang is a little bit misleading because it wasn't really an explosion. It was an expansion, and it happened really fast. And from there, everything came, like energy and matter. Some evidence is the redshift. Redshift shows things that are moving away from us. And we can actually tell because they shift to the red end of the spectrum, which means the light wavelengths get expanded a little bit. If things are moving towards us, the wavelengths of light would get a little bit smushed. They get a little shorter, and that would be more of a blue shift. So redshift is showing that things are moving away, which means the universe is expanding. Now, another little bit of evidence would be cosmic background radiation. This is radiation that exists in the universe, and it's left over from the Big Bang. We can't see it, so this picture is actually a false color picture. It's showing us evidence of it, but we can't actually see it ourselves. But we know it's there. We can observe it, just not with our eyes. Some ways we can see the cosmos. We have optical telescopes. These are the types of telescopes that you might use, in your backyard to go and look. They can be very large, like the one on the right. The two optical telescopes, the one on the right is up on the top of a mountain. We have X-ray telescopes. We have radio telescopes, and we have space telescopes, with the most famous one being, of course, the Hubble telescope, and that's what's pictured in the space telescopes. So how big is the universe? Well, we don't really know for sure, but we think it's about 93 billion light years across. That means light would take 93 billion years to go from one side of the universe to the other. That's pretty big. 1 light year. 1 light year is how far light goes in a year, and that's about 5.9 trillion miles. So that's a pretty big universe. How do we know how far things are away from us? So when we're looking at things in space, how do we know how far it is away? One method is called stellar parallax. This is a way that you can measure things that are closer. You've seen stellar parallax before, but it was just called parallax, and you just didn't realize you were looking at it. Next time you're riding in a car and you look out the window, you'll notice that objects nearer to you and objects further away from you seem to move at a different speed. So as you're moving, it seems like they're moving relative to one another a little bit differently. This is kind of how we do it. And if you look in the picture, the sun sits pretty well still and the earth moves around it. On one side of the sun, we can see where a particular object is. And then when we move 6 months of the year to the other side of the sun, we can see that object again from a different spot, and then we can compare the angles, and we can figure out how far away that object is. Another method is a little bit more complicated. It's called a Cepheid variable star. Now, these are bright stars that are in galaxies maybe a long ways away, and they get brighter and dimmer over a known period of time. And we can tell then how far they are using the physics of light. We can actually tell their distance because of this brightness, this brighter and dimming series that happens. So where are we? Well, we are located on the outside arm of the Milky Way galaxy, and there's a picture, On the top, that kind of shows about where we are. We're kind of way out on the side of this galaxy, and we're spinning around the center. Now, a galaxy is a system of millions or billions of stars, gas, and dust held together by gravity, and it's spinning around the center. Now, if you look at that little blue dot, the pale blue dot, that was taken by Voyager 1. Voyager 1 was 3.7 billion miles away from the Earth, and it was looking back at the planet. That's it. That's our star. I'm sorry, that's our planet. So, what is astronomy? Astronomy appeared a few thousand years ago as a descriptive science on the position and motion of sun, moon, planets, and stars. You can take it all the way back to the Greeks, but it really got going only a few hundred years ago with the advent of things like the telescope and, some really good, very detailed star plotting, although it's been happening for a couple thousand years. Today, it's more directed towards understanding the universe in physical terms, so astrophysics, so the physics of the universe. It is observational. We can observe the skies, but we can't do much with it. We can't manipulate it and experiment on it, with a few exceptions. So, where did the universe come from, and how do we know? What is the evidence that tells us where the universe came from? That's something to think about. How big is it? When we look out at the night sky, how big is space? And what are two ways we can use to figure out how far things are away? So they're covered in these slides. Two different methods we can use. That will be it for 5.1.